All right, today we're going to talk about a relationship in stoichiometry of moles to moles. And that relationship is seen in the chemical equation. So in the equation that depicts the decomposition of water into hydrogen gas and oxygen gas, we see a relationship. Now, we're just going to take a moment to think about what this means. This is not any different than in a situation where we have a recipe. And therefore, in a recipe, we can easily determine relationships when we look at the recipe. So I'm just going to erase this up here so I can show you an example. I have, let's try another color. I have 2 cups of flour and 1 cup of sugar as a requirement in a recipe. What that means is that for every 2 cups of flour, I am only going to need 1 cup of sugar. If I decide to double that recipe, then I am going to say 2 times the 2 cups of flour and 2 times the 1 cup of sugar. Therefore, I now have 4 cups of flour and 2 cups of sugar. But the relationship or the ratio is still 2 to 1. We are doing something very similarly when we are doing mole-to-mole relationships in stoichiometry. So what we now have is an example of 2 moles of water will decompose into 2 moles of hydrogen gas, but only 1 mole of oxygen gas. Remember, when nothing is written, a 1 is understood.